All right. Good morning, good afternoon, good evening, wherever you are, and welcome to this instance of the Antrea community meeting, which is going to be a slightly different than usual because today we have presentations from mentees in the mentorship program. Uh, I think we should have three presentations, one of them recorded. But before we go and look at these presentations, I would like maybe to have Antonin share a few words about the mentorship program and the work that various mentees have done. So, Antonin, if that's okay for you, I will hand it over to you for introducing the mentees.
Hey, thanks, Salvatore. Yes, so this term was our first time participating in the Linux Foundation mentorship program through the CNCF. So the CNCF is a sub-entity of the Linux Foundation, unless I'm saying something stupid, I hope not. And we proposed three different projects. So the way it works is that CNCF projects can submit project proposals on which mentees will be working, and the mentees are supposed to work on it almost full time for a couple months, and they get like a monetary compensation for their time contributing to the project. So it's a great way to onboard new contributors to the project. Typically, the mentees are university students. That may be a requirement actually to participate. And so, yeah, we proposed three different projects for Antrea. One project was to remove our dependency on the bean cover module to measure code coverage when running Antrea tests, and replace it with the Go built-in coverage tool, which was introduced, I think, in either Go 119 or 120. I don't recall exactly. And the second project was initially was to provide an installation mechanism for Antrea using the NCTL command line tool, but we realized that the scope of the project was too large for this, and so we kind of like reduced the scope, and it turned into writing some CLI commands to validate a cluster prior to Antrea installation, and validate the installation by running some connectivity tests after the installation took place. And the last project was to create like a latency monitoring tool between the nodes of the cluster, and have a mechanism to report that latency information potentially displayed in a dashboard for essentially some high-level network troubleshooting. So those are the three projects we had. And today we have Shikar in the meeting, who worked on the code coverage project. So it's my pleasure to welcome Shikar here. And we have Bo also, who work on the third project. I thought he was in the meeting, but it looks like it dropped. I assume he's going to come back. So he worked on the third project, which was latency monitoring tool. And Kana cannot make it today, unfortunately. He has an exam, I think. So he pre-recorded a video to present and demonstrate his project. So we're going to go through the three projects today. Um, I think we're gonna start with Shikar, then we'll move to Bo, and we'll do Kana last since he's not present. Sounds good?
Yeah. Shall I start?
Yeah, please. You can share your screen. Feel free to like introduce yourself if you want, and
Yeah.
then present your project. Yeah. Thanks,
Mm.
Shikar.
Yeah. Hello. I hope everyone can see my screen.
Yes, we can.
Yeah. So, hello, I'm Shikhar Soni. I want to talk about my experience as an LFX mentorship mentee at Antrea. So, a little bit about me. I'm a computer science undergraduate student from India. I am a member of Kharagpur Open Source Society, which is a student-led club at my university, IIT Kharagpur. I am also a new member to the Antrea community. Other than that, I am a casual photographer, a reader, and I watch a lot of movies. So my project was related to replacing the bin cover package with the Golang built-in coverage profiling tool. So Antrea has used the bin cover package since some time. In Go 1.20, they introduced the support for building instrumented binaries for collection of coverage profiles. Uh, and the process is very simple as building simple as passing a cover flag to the go build command, and then we can get the coverage data in different formats using the go cov data tool. The My implementation was pretty much simple and straightforward. Uh, so it I basically removed all dependencies on the bin cover and everything, all the extra things which bin cover used, and then introduced obviously the go build cover command. And so when a binary is generated using the go build cover flag, it expects a go cover dir environment variable where it will generate the coverage files. So this has been introduced in all the coverage enabled Docker files. Also, a run curve binary.sh script was introduced. It is basically a wrapper around the coverage instrumented binary. When the main process is killed, it sleeps and it waits for the coverage files to be copied from the pod to whatever the local machine. Uh, when coverage files are generated using go test cover flag, it generates a curve.out file which can be directly interpreted by codecov. But a binary instrumented binary generates curve meta and curve counter files, and we need to use the go curve data tool to convert them into curve.out files. So a basic workflow is as simple as when the test run is complete, it sends the SIGINT signal to the pod and the main process is killed. Then we wait for the coverage files to be copied from pod to the local machine. Then in the local machine, a simple bash script is run which converts all the curve meta files to curve.out files, and then they're archived, they're zipped and uploaded to CodeCup. Yeah. So yeah, these are the references which I use. This is my PR, and yeah, thanks for that.
Hey, thanks, Chikar.
Yeah,
And thanks for the work. I know it took longer than planned to to get your PR merged because of some testing issues.
yeah,
But we also uncovered a bug in Antrea thanks to that, which I've been working on fixing. So this was good. And Shikar also made like a couple of other contributions, I think, including one prior to the beginning of the mentorship program. So
yeah.
thanks for all of this, Shikar.
Mm.
Any questions from anyone about the project?
No, that was good for me. Thanks a lot for working on this. It's a good addition for Antrea.
Yeah, and
Yeah, it
always
So
good
was
to remove a stale dependency.
yeah, it was fun working on it. Yeah, I want to thank my mentors Antonin and Lan for helping me.
All right. I think we can move on move on to the second mentee now. So Bo, I see that you were able to rejoin. So yeah, feel free to share your screen. I know you have like a couple of slides and a video demo as well. And of course, you can introduce yourself first. Bo, can you hear me? You're muted.
Okay.
Oh,
Oh, okay. Sorry, I made some network issues. So I want to share my screen now. Yeah. Okay. Can you see my screen?
Yes, I can.
Yes. Hi, mentors. I'm Bo, and I'm the East-West connectivity monitoring tool for port network projects meeting. And my mentors are Anthony, Yang, and Alan. And I will start my introduction about this preview about from these three parts: the background, the design, and the live demo. And for this project, Antrea wants to provide networking functions for Kubernetes ports. These ports are located on different nodes, and which we want to detect the availability zones or even different geographies. And we want to support a monitoring tool to report the average network latency between any two nodes in the clusters. And for my design, first we want to create a feature gate for this feature and define a CRD for this monitoring tool. And we can see we need to create a new feature gate and create a CRD to define the pin interval, so we can manually define the pin interval in the clusters and get the node latency. And the second is to define the core monitoring tool here. And this node latency monitor contains these parts. The first is the latency store. We want to save the node latency in memory. And we have the flags to adjust the IPv4 and IPv6 network stacks. And we need two informer. The first is the node informer to detect the node up, node deletes, and the node updated events. And we can add the nodes to the latency store. And the second is the CRD informer. We want to detect the node latency monitor CRD is created or delete, so we can stop or start the load latency monitor tool manually. And the third is the Antrea client. We want to report the latency store from current agents and to the controller, so we can query the latency from the controller API. The next is we need to support the monitoring lifecycle here. If we enable the feature gates, the monitor tool is in enabled status. If we created the load latency monitor, the monitor tool will change to running states. And if we updated the interval in the CRD, we will re-update the load latency monitor interval in the current agents. If we delete this CRD, the monitor tool will stop and change the status to enable. And if we try to create a CRD, we will create two coroutines to send and receive the ping interval task here. We will try to ping all the nodes from the node informer and try to update the latest send time. We have another receive coroutine. We will try to use the receive loop to check the latest response from other nodes, and we will try to update the last received time and calculate the latest mirrored RTT here. And the third part is to report to the controller. We want to define a REST API in a REST API server. We want to enable the cluster rule defined in the YAML and use the Antrea API to create the load latency entry to the cluster, and we can export the get and the list API to query the latest latency in the cluster. And if we try to create the low latency entry, we will save the entry to the cache indexer in the memory. And the next step, we have export the API. So I have developed the integrated this feature to the web UI, so we can query the status in the web UI. First, we need to enable this API from the web UI server, and we can use this API from the proxy. And the next, I have defined a heat map components that we can show the data from the API. So we can take a quick look about the heat map here. We have created 3 nodes here, and it takes the latency here. And the next, I want to show a live demo about this feature. I have recorded a video here, and I want to play it. In the start of the cluster, I will check this script here. I want to pre-implement my local cluster here, try to create a new cluster and apply the Antrea YAML and apply the low latency CRD and check the logs here. So we can try to check the load latency defined. We have defined 10 seconds here in the cluster. We try to run this shell, and we will check it. We'll try to create the cluster and those latest image, and try to check the running state. And we will try to check the logs printed in the Antrea agents. So we will make sure that all the ports is in running state. And we're trying to print out the logs here. And we can see the logs is here. We have print all the nodes from 3 ports and receive the ICMP response from other ports and update it to the memory. And the next step, we want to use the Kubra API to query the latency from the controller. We'll try to check the API resource we have defined. We'll have exported the load IP latency states, and we use the Kubra control gate to query the last mirror RTT, last receive time, last send time. The last mirrored RTT is in nanoseconds. And the next step, I want to check the web UI here, and which converts, we have exported the Kubra config to my local machine, and we have started the web Antrea UI in Antrea UI server in my local machine, and start the front end here. It's exported in 3,000 ports, and I will check the this page. And we can see we have print out the controller config, agents config, and the load latency showed here is about 0 milliseconds, and I convert the nanoseconds to milliseconds. If we refresh the page, we can get the latest IP latencies here. And the next step, I will check the life cycles in the node latency monitoring tool. I will try to delete the load latency monitor, and we can see the socket is stopped by the load latency monitor delete events. and we will try to recreate the low latency CRD. Use Kubler control, apply this node IP config. And the CRD is recreated in the cluster. And we'll check the logs here. And we can see the load latency monitor CRD is added. And we'll try to check it. And we can see the load latency monitor is start, restart, and it runs well. Okay, this is a live demo about this feature. And the next is Q&A. If any other question about this project.
Thanks, Bo. That was a very, very cool demo. And yeah, we'll be happy to take any questions.
Okay.
Hi, Bo. Thanks for the work. I see from the log and from your design, there are two, even the server side, each agent would also be a SMP server. Am I right?
Yes, yes.
So I wonder why we don't use the native ping command, but needs to start a SMP server to for it to measure the latency. Is there any reason behind it?
Yeah. Actually, I just use the ping library to send and receive the tasks, and we try to use the raw library to control the life cycle easily. Yeah. We want to try to detect the low latency CRD, and we can manually start and stop the ping mesh. So we actually we have manually implement the ping server in this feature. Yeah.
I thought the kernel could respond to any ICMP.
No, I want to clarify this. It's we don't reply to ICMP messages. We let Linux reply to the ICMP messages. Yeah, we just send them and then we receive the response and we compute the latency, but we don't actually. We never generate the ICMP echo reply messages. The kernel does that.
Oh, I see.
Yeah.
The right part, receive task, is only to count the latency.
Yeah, because we put the timestamp in the ICMP echo request message, and then when we get the reply, we read the timestamp, we read the current time, and we compute the latency this way.
I see. That makes sense. From the log, the three ping requests for each node are sent almost at the same time. So I assume if every node also does this, could it cause some traffic? Could it cause traffic issues in production if this is a large scale cluster? Should we introduce some interval or some random latency before sending this request?
Yeah, we can put some jitter. Yeah. Sorry, go ahead, Bo.
Oh, okay. In this period, we just use the reuse the same socket. So you can see the three send logs here. We just use the same socket here. So we do not need to create the amount of socket to send task. So if the you have mentioned that we have a lot of ports here. So we will reuse the one socket and send the message in one socket and in one grouping. so we don't need to use a lot of we will cause we won't cause a lot of memory usage and other issues. So you have mentioned the interval. We just use the pin interval here. Maybe in the future we will use another more interval to control this pin monitoring tool. Yeah.
Yeah, thanks. I understand the packets are all sent via the same socket. My question was more for the overall traffic impact in the nodes network, because if each node will send one request to every other node at the same time, it seems that it could potentially cause some issues to the underlay network. But Anthony has answered the question that I think
Yeah,
the
all the
future,
nodes are gonna be, it's very likely that all the nodes are gonna be like sending them at a slightly different time, right? And sending one takes like a few microseconds, of course. But yeah, it's a good idea. We can have some jitter to introduce some randomness. Yeah.
Oh, okay, thanks. I will try to update this implementation to use the random time. Yeah.
No, but yeah, but not as part of your existing PR, but we can do that as a follow-up. Yeah. It's an alpha
Okay.
feature anyway, it's disabled by default.
Okay,
yes.
thanks.
So by
Yeah,
jitter,
hi.
do you mean? Sorry if I cut anybody, but by jitter, do you mean jitter between nodes or in the same node between the different ICMPs that they send to different nodes?
I think we could spread out the probes that we send over the duration of the period, right? For example, if we configure the latency monitor to send pings every 60 seconds, maybe we could find a way to spread sending all the probes over that 60-second interval instead of sending all of them in a tight loop as fast as possible.
Yeah, that
we
makes
could
sense. But that would also mean that, like, for example, on the web UI, at some specific time, some of the entries are like really recent, but some of the entries might be quite outdated.
Well, I think we talked about this before. It's all going to be quite recent, and all the nodes are in charge of reporting their latency information. So there's always like a time discrepancy between those already.
Yeah, that makes sense.
Okay, thanks.
Yeah, I have a question. From the heat map, it seems that the node also ping itself. Do we really need to let the node ping itself to get the latency?
In the latest commit, I have removed the pin itself. Yeah, we have removed the we don't need to pin itself. Yes. So in this figure map is outdated one. In the latest commit, I have removed the nodes. I won't pin itself and just to pin other nodes. Yeah.
Okay.
Okay, thanks.
Yeah, and by the way, all the numbers are very small here because it's a kind cluster, right? So it's always less than a millisecond latency. Any other question for Bo?
Looks like we can move to the next presentation.
All right, thanks a lot, Bo, for this great presentation. You went like above and beyond to incorporate like a UI component to this, so we really appreciate it. And yeah, we appreciate all the work you did during that mentorship program.
Yeah, thanks. I will try to continue to support this PR. Yeah.
Okay, so for the last project, it was Kana. We work on the CLI check, NCTL check command and his mentors were Chan, Lan, and me. And so he sent me a video of his presentation, I think, which includes a demo, and I'm going to share it now, and then Chan, Lan, and I can answer any questions that you guys have. So I'm going to try the video sharing function of Zoom, which I have never tried before. So let's see. Okay, it's a non-supported format. All right, so it doesn't like the MP4. That's a bummer. I'll try to share my screen instead. Right, I'm gonna play a few seconds of the video, and please tell me if you have sound and video correctly. I'm starting it now.
Hello everyone, so I'm Kana Gupta and I've been selected for the LFS Mentorship Term 1 for
All right, can you
Works for
confirm
me.
that it works?
Yes.
Okay. Thank you. I'm gonna restart the video now, and yeah, it's a 10-minute video.
Hello everyone, so I'm Kana Gupta and I've been selected for the LFS Mentorship Term 1 for the year 2024. And 2 months ago, I was very excited to interact with my mentors and work on the project and start the journey. And now here I am at the end of the LFS Mentorship term when I'm creating a to session of presentation to showcase the demo of the work done and explain what I have done. So I would like to begin the session by giving a quick introduction about myself. So I am from India and I am currently pursuing my bachelor's in computer science and engineering, and I am currently a final year student. And I've been open source contributor prior to applying for LFS mentorship, and the major experience till now in my open source journey was being a contributor in the Google Source of Code for the year 2023 under the Apache Software Foundation, in which I worked on the software that is known as Apache Sharding Sphere, and I worked in the field of parsing and compiler design. And after that, I've started a lot of exploration and like testing out various types of projects in this ecosystem. And out of these, I like the ecosystem of cloud native a lot. And I was exploring about Kubernetes, and that's why I realized that expert mentorship can be a very good form of a program which would help me accelerate my growth in this field. Therefore, I decided to apply for it. And I was right. I got to learn a lot about Kubernetes. I got to learn a lot about how the open source ecosystem of these cloud native softwares work. Yeah. And now I would like to start my presentation. So first I will describe my project. My project was to streamline the process of the installation of Antrea using its command line tool. So its command line tool known as AntCTL is being used for that purpose. And I worked on AntCTL, which shares of the same code base as Antrea. And other than that, we have like set up 2 testing frameworks and 2 new commands to streamline this process. So basically, installation process is divided into 3 steps. The first step is pre-installation step, in which we perform the checks of a cluster to check whether the cluster is in the right state or not for the Antrea to get installed and to get it up running quickly without any issues. So in pre-installation checks, we check whether the Kubernetes version is correct or not, or like above the required parameter, etc. And various other things in that. So it has a separate framework for it and a separate command for it. Second step is installing Antrea, and we can install Antrea by referring to the Antrea's official documentation. And there are various ways to install Antrea in the cluster. So any user who wants to install Antrea can refer to that. And the step 3 is post installation. And so in the post installation, we perform checks to basically ensure whether there is a proper form of connectivity in the cluster or not. So since the cluster contains a lot of different things like deployments, nodes, so we perform different types of tests to ensure whether these are things are able to communicate with each other or not. So I worked on the step 1 and step 3 under the guidance of my mentors. And also I would like to thank them for providing me this opportunity. So now I would give a demo of this. Okay, so as you can see my screen, this is the terminal, and since these commands are added to the ANTCTL, which has the same code base as Antrea, so I will like type the ANTCTL check cluster. So this command performs pre-installation checks on the cluster, and this helps us to know if the cluster is in the right state or not to install Antrea, and whether it will like give any potential errors if we install Antrea or not. So now I will like run this, and it created namespace, created a new deployment for it, and this performs 4 checks. First check is checking my existence. So basically, this checks if there is any other CNI configuration file of any other CNI available or not. So it checks whether if there is any CNI file which has higher priority than Antrea. There are a lot of CNI files which might be available in a cluster like Calico, Flannel, etc. So it checks that, and as you can see that Antrea is already installed in my cluster for the demonstration. So therefore it knows that the Antrea CNI configuration file already present. So the check is passed. Second one is check control plane nodes availability. In this, we check whether the control plane nodes were found in the cluster or not, and if not, it warns the user accordingly. Third is checking Kubernetes version. So Antrea requires the minimum version of version 1.19. So that is required to check whether the cluster version is up to date or compatible with Antrea or not. Fourth check is to check if the Open vSwitch kernel module is built-in or loadable or not in the cluster. So Open vSwitch kernel module is essential for Antrea to run. And if it is not built-in, we perform a modproc command to load it. And if it gets loaded successfully, the test gets passed. If it is also built-in, then also the test gets passed. Otherwise, if it is not built-in and also not able to load using a modproc command, then it throws the error or warns user accordingly. So this is the entire workflow of the framework that we have introduced to the community. It starts with creating namespace, then creates deployment, then wait for the deployment to get ready, then perform checks, and at the end, it deletes itself automatically. So there are no residual deployments left for the user to clean it, but clean them only. Now coming to the step 3, that is post-installation checks, I will now describe it. So now I will type a new command for it that we have introduced recently, ANTCTL check installation. Press enter. Since Antrea is already installed in my cluster right now, this test will get up running successfully. If Antrea was not installed, this would not have been started. So this shares the same workflow as the previous pre-installation check, and we use 3 deployments on this. 2 deployments on node 1 and 1 deployment on node 2. So the purpose for this is that it helps us to check whether the 2 nodes are able to communicate with each other, and it helps to check whether there is inter-node connectivity or not. Basically, inside the nodes are deployments and pods are able to communicate with each other or not. So this is pod-to-pod node connectivity. It basically checks whether the test client deployment is able to communicate to the node 2 deployment, basically, which is echo other node 2, and test client is in node 1. So basically communication from node 1 to node 2. Intranode means that whether it is able to communicate within the same node, 2 different deployments, 2 different pods, are they able to communicate with each other or not? Since they are able to communicate, my checks have been passed in my PC. Third one is pod to service internode connectivity. So this is also the same as pod to pod. Instead, it just checks whether test client is able to connect to the services created in echo other node and echo same node in the namespace which is created for this testing purpose. And these are the 2 test modes. And then there is a test which check where whether it is able to connect to the internet or not. So as you can see that this is the test which is able, in which shows that we are able to connect to the internet. Basically, we mean a cluster or a node. So we are using google.com to check internet connectivity. And as my cluster is able to communicate to the internet using Antrea CNI, it shows us that the test has passed. So basically, as we can see through the logs, there are no potential errors identified till now. And I would also like to add the note that this post-installation framework also supports IPv6 support. So even if the cluster is a dual stack cluster or only supports IPv6 or anything else like that, this framework can easily handle that, and there would be no errors that would come across with it. And other than that, at the time of recording, we have not yet implemented the Kubernetes network policy test or checks, and we will I will implement it before the term ends, before the LFX term ends. So that is also like new types of new tests are coming before this term period ends. So basically, we will check for the ingress and egress services, whether ingress and egress network policies, whether after applying those the connect is the connectivity being successful or not. Successful as in that it doesn't meet the condition or not, and are the network policies are successfully able to get applied or not in the cluster. So this is the complete post-installation testing framework, and you can refer to my contributions on GitHub, and you can also get to check for issues in the Antrea issues tab, and also get to know about the pull request merge under my name. Kana Gupta is my GitHub username. So these two tests are the work that I've been doing under the guidance of my honorable mentor. Now, also, I would like to explain that why we are doing that we are doing. So actually, the thing is that there are a lot of potential errors that a user might face if he does not know the current configuration Antrea requires in a cluster before installing Antrea. So basically, like a lot of things such as Kubernetes version and Open vSwitch kernel module. Personally, I have also faced an issue with Open vSwitch kernel module when I was using Windows. So I can relate to the problem myself, and I feel lucky to solve the problem which I faced myself. So it is like not even a problem. It just helps to add convenience to the user and make the process very fast for checking whether the Antrea can be installed or not. And same with post installation check. If there are any form of connectivity check errors in that, the user will get notified accordingly and can set up and configure the cluster and their own deployment manually according to the error message received. So this is the use of the two testing framework that we have introduced. So it will basically help you save time, increases your convenience, and helps to provide information about cluster whether the errors are there or not, and it helps the time a typical user takes to debug any error. If he does not know if he does not know why the error is occurring, so I believe that it will help in establishing a lot of convenience for the users in the community. And I'm glad to be a part of this project because I believe that it will help in adding more accessibility for using Antrea and also installing it. And that is it from my side. Thank you.
All right. Hopefully everything worked fine throughout. So yeah, we're happy to take any questions that you may have about the tools that Kana developed.
Is this PR already checked in or are we still reviewing it?
Actually, this one we've merged everything. Yeah, we've merged
Nice.
both versions of the command, so the pre-installation and the post-installation one. So yeah, you can already build it and run it locally if you want.
Nice. That's a very good addition to the set of tools that we have in the CLI.
And Kana wrote a blog about this. I promise I would put the link in the chat here, and I will also put it in the meeting minutes and in the description of the video recording on YouTube.
Cool.
So any other questions about this NCTL comment?
Waiting a
Anthony,
few. Yeah, go ahead.
so one, yeah, it is very nice addition, like all three features, and also like blog you're publishing, so it is also good. But post installation, especially for the last one, the post installation checks which you are doing, so that is without enabling any feature get, right? Like we don't have any IPAM configured, we don't have any other features enabled, right? It is a default Antrea installation, right? So do you have any plan like we can enable some features and do more checks for the post installations?
Sure, I can take this one. Chen, feel free to complete if you want. Yeah, I think at the moment we're only running like generic checks that would pretty much work irrespective of the features you've enabled. And yes, in the future we can. So the idea is to have tests that work based on the configuration in which you've deployed Antrea, right? So in the future, we may look at which features have been enabled for the cluster, and based on the Antrea configuration that we can read, we can decide if we want to run some specific tests, right? For example, if proxial is enabled, we could imagine running some tests to validate that the proxial is running correctly. Although in this case, those tests could run pretty much regardless of the configuration, because if proxial is not there, you would expect kubeproxy to work. So maybe that's a bad example. But yeah, what other example comes to mind? Well, egress is enabled by default. Maybe we could have some check to verify that egress is working correctly. But yeah, the base idea is that we can look at the Antrea configuration, and based on the configuration, we can run some different tests. Just like for end-to-end tests, we skip test if like the feature that's being tested is not enabled. So we could have like a similar approach. But the purpose is not to duplicate what to do for end-to-end tests. So we don't want to have like as comprehensive of a coverage, and at the same time we want to ensure that those checks can complete very quickly. So the idea is to incentivize people to run it after an installation, and so at least in its default format, we don't want the test to take like 10 minutes to run, for example, and we don't want to duplicate the efforts with the end-to-end tests that we have.
Yeah, I mean default format looks fine. Yeah.
Yeah, maybe a good example of this, of the post installation, is one use case received from users. Antonio, I remember you mentioned this case before, is that a user enabled WireGuard encryption in the cluster, but they don't know whether the traffic is really encrypted, and they don't have enough knowledge to verify that. And we have to share commands and to basically to interact with WireGuard CLI to check the status. However, if we could add one post installation check, and which will run when the WireGuard tunnel is used, and it could verify that the traffic is indeed encrypted. I think it could be very useful for this user.
Yeah, thanks, Chen. I totally forgot about this. Yes, that's an idea I had when talking to a user. We can give them confidence that encryption is working as expected. Yeah. Thank you.
Yeah, and maybe add some more feature gates like IPAM, egress, and proxy all, as you mentioned. Yeah, we can.
As for pre-installation check, I feel one possible mode to enhance it is to integrate it with the installation tool that we don't have at the moment, which basically means that when you want to install Antrea with a specific configuration, for example, if they specify the feature gates or configuration they want to mutate, and we this configuration might be the an option of the installation command, and we automatically use that command, use that configuration input to get a user's intention of which traffic mode and which feature they want to enable, and we automatically run some checks related to checks checking the requirements of such configuration, and warn them whether this feature could work in this cluster. But at the moment, I think we just for the very basic existing pre-installation check, we just run off them, and we just for features, for requirements that we don't know whether user will really use them, we just return an error saying that we are not certain whether this will cause a problem. That's why when the pre-installation, the check cluster commands finishes, there is statistics about succeed, failure, and uncertain checks. For example, the second check, control plane node availability, would not cause an error even if the control plane node is not there, because on some cloud this is expected. But if user want to use some features relying on control plane node, they won't be available. So we just warn users about the uncertain result, but because we don't know user will use that feature or not.
Yeah, I think that makes sense. And to Rajnish's point, I think I mean he mentioned IPAM, right? I guess one thing we could check as a post-installation check is when flexible IPAM is used and enabled, we can make sure that it works correctly, for example, by creating an IP pool and annotating a namespace, doing something like this. I mean, it becomes a bit involved, right? But that's definitely something we could do. Again, it's kind of like really easy to start duplicating efforts with like end-to-end tests once we go that route. I guess an argument could be made that there is potential for some unification there between the connectivity checks and end-to-end test, in that like the first one could be a subset of the latter. All right, I think we're almost at time here, Salvatore. So I just wanted again to thank all the mentees, the three mentees that participated in that term of the mentorship program, and of course thank all the mentors that assisted them in their project. And I hope this was like a very useful experience for everyone involved.
Yes, thanks, Antonin. And I also would like to thank all the mentees and the mentors. And congratulations to all the mentees for the great work they've done. And, I'm obviously looking for more contributions in the future. And thanks again for the mentees for presenting these very interesting activities. And I believe that it might be all for today. So I would like to thank everyone for attending the meeting, and we'll see again in 2 weeks' time. All right, thank you, and enjoy the rest of your day. Have a good day, good afternoon, or good night.
Thank you.
Thank you.
Yeah,
Bye-bye.
see you.
See you. Bye.